Hi, everybody. My name is Mano Marks. I'm here to talk to you about building scalable Geo web applications. With me is Keith Golden and Jeffrey Sambells, and they are going to be handling different portions of it. Normally, when I give these kind of presentations, I like to encourage questions during, and I'm going to not do that this time. We have a lot of area to cover, and so we're going to save questions for the end. So please, if you want, there's a moderator page for questions. If you have a question and you don't want to forget it, put that in there, and we'll get to those. And also at the end, we'll have questions for the microphones. So I'm going to go ahead and get started. Okay, so I'm going to spend a little bit of time talking about what it means to be scalable. The main problem with building a web application these days is that, from my point of view, is that people end up actually using it, and the danger in people actually using it is then your application might go down. I think everybody here has probably heard the term /dotted, where your application gets posted to /dot or dig or some other popular website, and then a whole bunch of people go to it, and then it overwhelms your servers. So what we're going to talk about today is how you can take that load off of you and your servers and put them onto us. So we have three basic approaches to that, which I'll mention, but let me just quickly run through some of these difficulties. Well, the big one in the center is the users. The users are the main problem, as I said. If you have to build your own application infrastructure, if you have to build your own servers, you have to load balance, maintain your machines. You have to invest a lot of time, energy, and money. You have to shard your databases. And you spend all this time doing things that are not building web applications, but really maintaining it and making sure that it stays up. Now, some people really love doing that, and a lot of them work for us. I'm guessing that a lot of you don't like doing that and would rather just focus on the content creation, and that's where we're going to talk about. Okay, so a few things to think about in terms of building scalable geo applications in particular. You want multi-format output. That is, you want to be able to serve it in Google Maps and KML, in open layers, in whatever formats that you can. You want to be able to do specialized spatial queries, so be able to do bounding box queries, at least, radius searches, that sort of thing. You want it to be highly customizable. That is, I'm guessing the vast majority of you want to design your own applications, run your own applications, and have it be special to you. And you have, as programmers, you have your own quirks and things you want to do. And you want to rely on open geo standards. You want to support open geo standards like KML and GRSS. So that goes along with the multiple format output. So here's the handy dandy little matrix where you see I cleverly highlighted in blue the answer. But basically, we're going to talk about App Engine, the Google Maps data, the Maps data API, and Google Base. I'm going to talk about the advantages and disadvantages of them, and you'll see that that for the most part, we have a very good coverage, and we're going to talk about some of the weaknesses as we go along as well. Okay, I'm going to talk about Google Base, and I'm doing this first because I kind of want to get it out of the way. There's a number of people who just want to give data to Google and have Google store it and then do something with it. And we have this giant, what I think of as this giant XML repository called Google Base. It's the back end of a lot of services that you might have used, like Google Product Search, which I still want to call Frugal, and various other things. It's got it's the back end for a lot, as I said, for a lot of our services. If you put data into it, it becomes easily discoverable in search, and it supports bounding box and radius searches. It's got a Google Data API. It's got a lot of the things that you want. One of the things I want to point out at the end is the upload times can be kind of long. Fundamentally, when we're talking about the Google Data API for Google Base, The Google Data is one of our basic protocols for accessing Google services, data in Google services. So I want to mention that for base, it's got that. It's got a Google Data API, which means it supports a lot of client libraries that we've already developed for that. There's a lot of support in general for the Google Data APIs. But there's not a ton specifically for base, so this is one of the reasons that we don't encourage people to use it a lot. I want to point out here, just give you some code samples here. This is how you put an item into base. This is a personal ad. A surprising number of personal ads in Google Base, actually. I think that's to increase their discoverability. A lot of the search engines like Hot or Not put their data into Google Base. You'll see here there's an atom entry. It's got a title. It's got an item type, a location, gender, marital status. You see there's a lot of sort of customizable, but also a lot of standard attribute data. I'm going to just mention this briefly. I'm an XML head. Atom Pub, which is the basis for Google Data APIs, uses this term attribute. And of course, in XML, an attribute means something completely different. But basically, an attribute is, like you see here, location, gender, marital status. So to repeat what I said earlier, there's a number of standard attributes, and then there's also, you can customize your own personal attributes. So you can basically treat it as a big schema-less data store. And then here's a sample spatial query. So of the products I'm going to talk about at the moment, Base actually has the best spatial query support built in. And it's important, that phrase, built in. And that is that it will allow you to do bounding box and radius searches based on a straight-up query. So you'll see here, this is one long URL that I've broken out into these 3 lines here. So you've got your basic snippets feed. You've got the query, which tells the type, and then the location, and that's how you get all the personal ads within a certain within a radius of those latitude and longitude coordinates. Okay, I'm going to talk now about App Engine. So Google App Engine is one of our premier developer platforms right now. I think you probably have seen the number of different sessions that are available on Google App Engine. You'll have seen during the keynote they announced that we've now opened up the Java runtime to anybody who wants to sign up for it. So we're putting a lot of energy and effort into App Engine, which we're not doing quite as much for Base. So what you have in it is a high-performance, high-availability, easy development server. You can use Python or Java on it. It's free to get started, and it's built on Google infrastructure. And when I say that, they're all built on Google infrastructure, but you're actually building applications in a way very similar to the way that we build applications at Google. And in fact, a number of our applications, like Google Moderator, are actually built on top of Google App Engine. So basically, with Google App Engine, you run your own applications, but you're running them on our servers, and we handle all the issues around scaling and denial of service attacks and all those kind of things. And backups. So here are the advantages of it. It's built for scaling. It's replicating data centers around the world. You can use standard Python or Java libraries, although I will point out that you can't use anything that relies on C libraries, which unfortunately takes out a lot of the standard Geo, the Geo libraries like GDAL, OGR from use. We have easy authentication. You can authenticate using Google accounts very easily, and it's highly customizable. Anybody running the application would have no idea that they were running it unless you told them. disadvantages for spatial applications is very limited spatial support in queries. And particularly, it has a limitation on inequality queries. So you build a model, you put it into of something, you put an entity into the data store, it has a number of properties. When you do a query on that, analogous to a relational database, but not the same, you do a query on the different properties, and you're only allowed one inequality on one property. Sorry, you're only allowed inequality on one property. So what you could do is you could say, give me everything with a latitude between x and y. So that's an inequality on one property, greater than x, less than y. But you couldn't then also do an inequality on longitude. And the reason for this is that it's built on top of a highly distributed database. These things, you're creating an index which might span multiple machines, and there's no way to keep track of two properties in that query, in that index. And that's just fundamentally we're exposing to you one of the limitations that we also work with in building applications. It's also a very different way of building applications than most people who start out developing a spatial application start out with. It's not, you can't use PostGIS, you're using our data store. You can't use any of the standard spatial databases or libraries. You're really creating a kind of cooler way of doing things, but you're working within these limitations, and you're doing it in a way that would be unfamiliar to most of you. So let me show you a few code samples from Google App Engine, and then talk about approaches that people have made to get beyond these limitations. So this is a very simple model. You see it in, got the import, you define class myLocation, you give it a name and a location. You'll see right there, it's got this GeoPoint property that sounds very exciting. When I saw that the first time, I was very excited, and I thought, great, we're going to have great spatial queries. Unfortunately, you don't get very much for that. So here's a simple query to the data store. After you've put any item into the data store, you use a GQL query, Google query language, and you would just say myLocation.gql where name equals something. And that :1 and foo, that's a substitution process. So let's see, did I put in a slide about ordering? No, I did not. Okay, so the only thing that this GeoPoint property gets you is ordering. So if you order your query by the location property, you'll get things in order from north to south and then east to west. North to south, east to west. Okay. All right. So let's talk about some of I'm going to talk about two approaches that people use to get around this. The first one is geohashing. This is a fairly common approach right now. I was talking with people just last week at WhereCamp. Somebody was saying they built based on this. It's geohashing is you take the latitude and longitude and you hash them together to create a single value. So in one inequality query, you can query based on a string match on this hash, and you use only the one inequality query inequality in your query. So it's built on an open source library, which is available in Python, which means it's easy to use and very easy to plug in, and basically allows you to do a simple radius search on your properties. I'm not going to show you an example of it because there's a few places that it falls down, particularly around the international date line, and the disadvantage is it still uses your one inequality query, right? So the idea here is to allow you to do an inequality query on some other property. So say you're doing a real estate search, you want to get all houses within a certain radius, but you also want to get them in cost between $100,000 and $250,000, which precludes you from getting someplace in the Bay Area, but that's that being my point. Okay, so let me talk to you a moment about Geo Model. This was actually developed by Roman Nurek, who's actually sitting in the audience today. We can all cheer him. This is the approach here is to pre-compute something's location, essentially. You're dividing the world into a 16 by 16 grid, and then each of those things into a 16 by 16 grid. It's a quad tree, but it's a 16 tree instead of 4, whatever that would be. And then you assign your entity to a cell at each different zoom level. So that's the basic approach. And then when you're doing a query, you basically figure out what zoom level you're at and pick out the individual cells that are appropriate for your bounding box, and then you find everything that matches that. And the advantage is that it places you're doing equality queries instead of inequality queries. You're saying, give me everything in this cell, and that cell, and that cell, and that cell. And that way you build up a result set that you can then return to the user. So the advantage is it doesn't use the inequality query. And it's customizable with different zoom levels, resolutions, and grids. It's also, by the way, an open source library, so you can customize the library however you want. Develop your own algorithms for assigning cell numbers. The disadvantage is it's kind of complex. And it also doesn't scale as well with other geometry types. Right now it's optimized for point data. So it's hard to give it to somebody and say, here, get started with this. There's a learning curve that's involved. So I've got some code in here, and I don't have a ton of time because I want to give Keith and Jeffrey the bulk of this time to talk about the Maps Data API. But just to give you this, and then when these slides go up and they're published, then you can go through some of the code, or you can just go directly to look up Geo Model on Google Code site. And I just want to give you a short example of this working here. This is geomodeldemo.appspot.com. And what Roman did was he took GeoNames, took the database from GeoNames, and took a whole bunch of locations, I think just in the United States, and uploaded them to App Engine. I think it had 100,000-ish records, something like that. So we'll do a search center of San Francisco, California, and do a search. And so you'll see that it's kind of chews through quite a big data store and comes up with top 10 results or so, and then also puts the center in there. And now we're going to do an inequality query, the minimum population, so something greater than 50,000. And so here it finds the locations in the GeoName database that have populations of 50,000 or more within a radius from San Francisco, setting the center at San Francisco, and then displays it on the map. And you'll see his demo also very nicely then figures out what the bounds are of that search and resets the map to it. Okay. And I think that is it for Google App Engine. So I'm going to hand this over to Keith.
Hi, I'm Keith Golden. I'm a tech lead of the Google My Maps team, and more generally various user-generated content efforts within Google. And I'm very pleased to say that a few weeks ago we launched publicly the Google Maps Data API. So what exactly is this? Mano talked about how Google Base has a a Google Data API. So this is a Google Data API specifically for Google Maps. So specifically, it's designed for storing geospatial content, and it works closely with a number of Maps capabilities. So in particular, it works with My Maps. Anything that you create using the My Maps editor within Google Maps, you can access using the Google Maps Data API, and vice versa. Anything that you create using the Data API is accessible via My Maps. Now, all Google Data APIs are essentially Atom hubs. So this is this is an Atom. It's basically a standard XML representation for both getting and modifying data. We currently support 3 types of geometry: point, polyline, and polygon geometry. Basically, what we support right now is effectively limited to what you can actually display in Google Maps with My Maps, but we don't intend to stop there. Anything that you create that you indicate as public will be searchable on Google Maps. So we index it all for you, we make it searchable for people who go to maps.google.com. We do provide a few capabilities that are not currently part of the My Maps user interface. So, for instance, we support user-defined attributes, which can have some structure to them. You can define a type for your data, for instance, and units. We support efficient batch operations, and we also support efficient kind of incremental operations. If you have an application, so for instance, you all have one of these little toys. We have a couple of applications written for the Android. That's a My Maps editor and an application called My Tracks. Both of these applications use the Google Maps Data API. And one of the problems with a mobile application is you might have a very large amount of data, but you don't want to be sending a large amount of data continuously, over over a very limited bandwidth. You always want your data to be fresh. So I might have thousands, hundreds of thousands, perhaps millions of points. But maybe only a few of them have been updated recently, and so I only want the few that were updated. And similarly, if I make a few edits on my phone, I just want to send those edits over. The latter is something that works very naturally with Atom Hub, and the former is something we support updated min and show deleted parameters, which basically say, I can say, give me everything that's been updated in the last minute, and also let me know about things that were deleted. And finally, one advantage of Google Data APIs is there are client libraries in a variety of languages, and we have some custom libraries specifically for the Maps Data API. So in Atom Pub, all the world is represented in terms of feeds and entries within those feeds. And so in the Google Maps Data API, there are 2 types of feeds, what we call a Maps feed and a Features feed. A Maps feed is a list. It's essentially the list of all your My Maps. A map is simply a collection of features, and a feature is some particular element that you put on the map. When if I request from the API my maps feed, what that's giving me is just a list of all the maps I own, very simple amount of metadata, some access control information, title, and then the main thing that's of interest is in the content element of the entry, there's a source attribute, which is references a features feed, and the features feed lists all of the individual features within that map. So to actually list your maps, you use the maps feed, and to list the contents of a map, then you load the features feed. And the features feed also is fairly straightforward. There's not much in the way of kind of non-standard Atom pub attributes. The bulk of the information is specified in the content tag of the feature entry, and the content is simply it's KML. So KML is an Open Geospatial Consortium standard that was originally written for Google Earth. And we don't currently support all of KML. We're actually working on supporting all of KML right now. As I said, we basically deal with the subset that you can conveniently display in Google Maps. But we're working on kind of more interesting 3D geometry for Google Earth and some of the more interesting structure that KML supports. So currently we support 3 kinds of geometry: line, polygon, and point geometry. All requests using the MapState API currently require authentication. We need to know who you are to know whether you actually have the right to do what it is you're trying to do. So for instance, editing a map that you own or that you have rights to edit. And there are 3 different choices for how you do the authentication. There's auth sub, OAuth, which is kind of open standard, and then client login, which is appropriate for non-web applications like Java programs and useful for other purposes as well. And one just little important bit of information: if you use client login, you need to specify. It asks you for a service name, and the service name for that is local. So this URL here is this is kind of the top level entry point. If you send an authenticated request for this URL, this will list all of your MyMaps, basically, all of the maps that you own, whether created through the API or in the MyMaps user interface. And then from there, you can drill down. You get other links that reference individual maps and then features within maps. In Google Data APIs, we actually use 4 different HTTP actions. So in addition to the normal get and post, there's also put and delete. So if you send a GET request with this maps URL, this says, give me the list of all my maps. If I do a post to that URL, then that is used to create a map, to add a new map to the feed. If I do a put to the URL for a particular entry, so you get an entry URL back whenever you do a post, then you can use that to edit the metadata of the map. And finally, if you want to delete a map, just do an HTTP delete. And you can also, among the metadata, you can specify the access control, specifically whether it's public or unlisted. So similarly, there's a feature feed, and again, we support get, post, put, and delete. Get will list all the features within a map. Post can be used to create a new feature. Put to edit an existing feature, and then delete to remove a feature. And we, in addition to the KML, we support a custom property element, which allows you to define custom attributes for, and again, as Mano said, there's a confusion with XML terminology versus Google Data terms, but you can define custom attributes for your features. So here's an example. So the interesting thing to note here is that actually most of this is just KML. So basically what we're doing is we're taking a KML place mark and we're wrapping it up in an Atom entry. So as I mentioned, anything that is public, and public is the default, anything that's public is going to be potentially searchable, findable on Google Maps. And you may not want that for everything. If you want your map not to be indexed, you can use the app draft tag, which has to be wrapped up in an app control, to specify that this is something that's unlisted, that is not for public consumption. Now, another important thing is attribution. Now, as I said, all these requests are authenticated. Whenever you create a new map or create a feature, we know who you are, or at least we think we know who you are. And so by default, we always try to attribute any feature that was created to who the user is who uploaded that feature. But that may not be correct, right? Maybe you want to create a Maps API site, community site for, say, bicycling maps. So you want everyone to go to your site and upload their bike route, and you want everyone to be editing the same data, right? And a logical way to do that is you have a single account, and you've got some server running, some proxy that is authenticating all the users under that account, right? So the user isn't logging in, as herself. The user is logging in as you, basically. And then, but you may have your own account management. You may know something about your users that we don't know. And so if you want to override the default attribution, you can do so, and there's a standard way to do that in KML. KML accepts the atom author and atom link tags. Atom author can be used to specify who the real author of something is, and atom link can be used to specify a web URL for this particular resource. Because by default, we'll just, if something shows up in search, we'll just point someone to the My Map that contains that data, display it in Google Maps. But maybe you don't want that. Maybe you have your own API site to display that data in a more reasonable way using the custom attributes that you've defined. And so you can use these tags to customize that. Now, the examples I've shown you were all HTTP and XML, but you don't need to talk HTTP directly. There are client libraries in a number of languages. Right now we have custom libraries in Java, JavaScript, and as of yesterday, we now have Objective-C. And other custom libraries are in the works. There's also generic libraries that also work. So for instance, if you want to do something in Python on App Engine, of course you can use the Java libraries in App Engine, but if you want to use Python, there's generic Python library. We don't yet have custom Python libraries, but the generic ones will work. And Jeff is going to be talking about a custom library for PHP that his company wrote. And finally, right now, all of the data is expressed in KML. We do intend to support other formats in the very near future, but right now it's just KML. If you want code to help you parse the KML, we have that also available for download. There's something called libKML. The code is written in C++, but there's SWIG bindings for a variety of different languages. And here's just an example, a very simple kind of stupid program written in Java, just to show you how the client libraries work. So the first thing we're doing is we're just constructing a URL for a particular feed. This is the feature feed for a particular map. We're specifying what the name of our service is, and then we're using the set user credentials to do a client login, just manually specifying the username and password rather than doing something to have the user type that in. We then get the feed. Now, all these requests are synchronous. So when we do a get feed, when we come back with the result, the feed is actually immediately available. We have Java objects for all those things. So then we can immediately go and iterate over all the entries in the feed. And so all we're doing here is we're adding a new custom property for each entry. And just to kind of make this example really simple, all we're doing is we're defining the custom property to be what we call an annotation property. It's just something that I made up. And we're setting the value of that to the title of the entry. So then we just call my service update. Now again, this is synchronous. So we're going to have this synchronous operation once per entry. This isn't going to be very fast. If you really wanted to do this in practice, it would make much more sense to use the batch operations. And there's information available on code.google.com, slash I think APIs/GData that tells you how to use batch operations. So that's it, for right now. We are furiously working on getting new capabilities added. There are a lot of things, gaps that we know exist and that we know are important to all of you. And we're also interested in hearing anything you have to say, any suggestions you have on how to improve this. So certainly, we need to do better with search. We're working on, so all this stuff is searchable, but it's not right now searchable through the data API. We're working on richer content, better integration with the Maps JavaScript API, and new kinds of feeds are in the works. So that's it.
Is the screenshot there, or was there a screenshot not with it? Or was there not a screenshot there with it? Fine, it's fine. Don't worry about it. Hi, everyone. I'm Jeff Sambells, Director of Research and Development at WeCreate and co-author of being Google Maps APIs. I've been asked to talk a little bit about the Google Maps Data API and how we've integrated into our site and how it benefits our users and our developers. So to begin with, WeCreate has developed a site called connectorlocal.com. It's a site focused on delivering high-quality, hyperlocal information. Let's pull it up here. Oops. Sorry. As you can see here, we've integrated places into our site, and here we see a few places in connectorlocal.com around the Moscone Center that I've added previous to here, and it's all information based around our central location here at the center. And we've chosen to integrate Google Maps because it allows our users to easily share their information back and forth between ConnectorLocal and the Google Maps. If we take a quick look at the Google Maps page, we can easily create a map. We can quickly create a map. Let's call it Google I/O. And using some of the places that we've already defined in ConnectorLocal, we can pick from, let's say, a few hotels in the area and export them to our Google My Maps account. Now, as we've already discussed, these maps or these items now become available in my account, and if we log in, we can see that here we go. The map is now available, and it contains the few places that I selected previously. So this gives our users a great opportunity to take the information that they've assembled in local and share it with other users who may not be part of the ConnectorLocal system. And this also brings me to another point, that ConnectorLocal had a problem with how to get all the information in its site into the search index. Because if you think about it, the search engine has a hard time understanding geographic relevance of the information as it's presented through a standard web crawler. The search engine doesn't really have a solid location or any underlying desire when it visits the site. So we needed to find some solution to take that geographic relevance and submit it to the search engine. Well, the Maps Data API is perfect for this because we can take all the underlying information, package it up with its geographic relevance, and submit it right to the search engine for indexing. So we can also, as well as our users sharing information with Google Maps, they can also take their existing Google Maps information. So here I've got a few other maps and import those right directly back into Connector Local. As you'll see in my Google Maps area of the site, I have a few maps, including the one we just created, available for import. I'll take a previous map that I've created and import it with just a few simple clicks. And now a lake, and actually 2 lakes that were in that map, are now added to my places. So this lets me easily retrieve the information from my Maps account and now include it with my Connector Local information. So if we take a I'll flip back to So if we take a look at the bit of code that we're using to do this, WeCreate has developed a library wrapper for PHP to access the Google Maps Data API. It's free to download. You can download it at the link there, and we're working on including it directly in the Zen framework itself. Here we see all the examples that I'm going to be showing in a moment assume that you've already authenticated with the service and have instantiated the object. To authenticate, as we previously discussed, you can use authsub or the client login if you already know the username and password. So here we see a quick example of retrieving the map feed, which lists the existing maps in my Google My Maps account. So we just simply instantiate a new query and pass that query into the maps feed, and we can retrieve a nice PHP formatted object with the ID, title, and summary attributes of the map. So retrieving the attributes of the map are okay, but you're probably going to want a little bit more information, which is where the feature feed comes in. Again, fairly simple. Create the new feature query, pass it into the feature feed, and you can retrieve your features. But the feature feed actually contains a lot more interesting information in the place marks. And our PHP library wraps the KML entries into a nice object format, so instead of dealing with the KML itself and parsing it, you can just simply retrieve it through the object. So if we wanted to create a new map, again, very simple, create a new map entry, assign it a title and a summary, and insert the map. When the map's inserted at this point, it becomes part of the My Maps account, as you saw earlier. But at this point, it has no features or anything interesting in it besides the title and the summary. So you're going to want to add some new features to it. To add a new feature, you have to start working with those KML place marks. So the place marks example here, I'm just creating a very simple point for the Moscone Center. And this is a very simple example that we could extend to include additional points, lines, polygons, as well as style attributes for things like colors, the line weight, icons for these points, and all that kind of thing. So that's just a quick introduction to the PHP library. You can feel free to use it, and I'll hand the talk back over to Mano and open up for questions.
we're going to open up for questions now. If you have any questions, come up to the microphones or go over to Google Moderator, where we have no questions so far. Let me refresh that. So, any questions? Anybody has?
You talked about having polygon support. So do you have holes in the polygons as supported?
No. As I said, so short answer is no. As I said, we currently are limited to what the MyMaps editor supports, and we're furiously working on erasing that limit. But right now, there's no support for multi-boundary polygons.
And you mentioned search by location that's coming. What sort of searches will be possible?
Well, certainly, radius and bounding box type searches, as well as keyword and attribute search.
You're not thinking of doing search by arbitrary polygon rather than just bounding box? Intersect.
That was actually search by arbitrary polygon was the most frequently requested feature capability that I've heard from developers. And so, yeah, that's definitely on our list. I can't tell you exactly when. Certainly probably would do first, release, radius and bounding box search, and then, the polygon search. But that's certainly something we'll work on.
Thanks.
Other questions? All right. Normally at this point I would say I would go out and ask you questions, but it's late in the day, so. Oh, go ahead.
So your talk was about scalability with geo applications. So when you talk about storing data in MyMaps, what are the scalability limitations? Can I throw millions of points into MyMaps? Can I throw,
Yes. So first, the good news: there are no intrinsic limits. You can have millions of place marks in a map. However, we do currently have quota limits, and the quota limits right now, the default per user limits are low, just because we don't really know what to expect, and we want to, we don't want to get an unpleasant surprise. But if you have specific requirements and you need higher quotas, talk to us, and we can easily accommodate that. Our intent is not to limit the developers out there. The intent is just to make sure that we can provide provide the level of service that we need for as many users as possible. Now, you may find that certain things maybe don't perform quite as well when you have large numbers of points, a small number of points. There are things So in particular, right now, given that the way you can access a feed is load the feed, maybe kind of page after page, that's not going to give you a very good experience for large numbers of features. In addition to the search, which certainly addresses a part of that, there are other things that we're working on that unfortunately we're not yet in a position to announce anything about, but I think will definitely give you a good experience for large collections.
Yes.
Everything's done over HTTP, right? No SSL. Is there any possibility that'll change?
Yeah, currently it's all HTTP. That's something. If there's a really compelling need for it, talk to us, and maybe we can add it to the to-do list.
So no My Maps for My Domain ready to announce right now?
No, not at this time. That's certainly something that we're very aware of the need for that. and it's on our roadmap, but we don't have it currently. So currently it's only your normal Google account, no apps for my domain accounts. It's basically the same limit that applies to really everything under Google Maps right now. We just don't have that support yet, but it's on our roadmap.
Any more questions? All right. Well, enjoy the party tonight, and I hope to see you there. If you have any more questions for us, we'll hang around here for probably another 10 minutes if anybody's still here. So, great. Thanks a lot, everyone.